These are the 10.6 notes for trig. We're moving on to something a little bit different here. These are called complex numbers, and we're going to go from rectangular to polar, just like we did with our x, y's, and our thetas. The only difference here is these are going to have an I. So when we talk about complex numbers, we're talking about i's, those imaginary numbers. So on the box on the left, you have your rectangular complex numbers, which have the x and the y, and the I is attached to the y. And then for polar complex, you have r parentheses cosine theta plus, again, there's your I sine theta. So we're just adding on a little bit of an I. It's very similar to what we've done before. Notice the box on the right has the same formulas. So we'll convert these the same way and just make sure we put it into the correct format at the end. When we graph or sketch out anything, the real number is going to go on the x-axis, there it is. And then the imaginary number will be on the y, which makes sense because you have the x here without the I, and then the y is attached to the I. So this is similar to what we did earlier when we were just plotting to see which quadrant something falls in. So if I plot 2, 5i, I would go 2 to the right and 5 up for the imaginary, and that would put me in quadrant 1. Negative 1, 3, left 1, up 3. That would put me in quadrant 2. So we're pretty much just plotting the numbers, ignoring the I. For negative radical 5, again, I don't care about what the number radical 5 is. I just care about the direction. So 4 would move me to the right, and negative radical 5 would move me down. Not worried about too much where it falls, as long as I get it into the correct quadrant, would be quadrant 4. And then negative radical 3, negative I, which would be like having a negative 1i. Negative, negative would fall into quadrant 3. All right, now let's convert. We're going to convert each polar complex number to a rectangular complex number. Express your answer in simplest radical form. So this is going to be my r and my theta. The theta actually shows up twice in each problem. It's always going to be the same, whether it's with a cosine or the sine. And we're just going to switch these out for x's and y's. So 2 cosine pi over 6 and y equals 2 sine pi over 6. And I'm not going to attach the I yet. I'm going to wait till the very end and attach the I at the end. 2 I'll write as 2 over 1. Cosine of pi over 6, I have to use my unit circle. Pi over 6 is here. So cosine would be the x value, getting me square root of 3 over 2. I'll cross cancel the 2's to get x equals square root of 3. Same process for the y. This time I go to sine, which will be this one right here, and that's the x, that's the y, so I'm going to use 1/2. And the 2's can cross cancel, the 1's cross cancel, and I'm left with 1. Now, instead of just writing this as an ordered pair, we want to write it back in this format right here. So you want to write your answer as x plus yi. So x plus yi. And there we have it. You could leave the 1 off if you chose, but feel free to put it there if you need. I believe Delta Math accepts the 1 there. All right. The next one, I've got r is the 4, and theta is 3 pi over 4. So 4 cosine 3 pi over 4, and 4 sine 3 pi over 4. 4 over 1. Now I have to go find 3 pi over 4 on my unit circle. Let's see, here it is. So we'll take the x first. negative radical 2 over 2. And we'll just simplify here. So a 4 and a 2 can both be divided by 2. So I'll divide that by 2 to get 2. Divide that by 2 to get 1. Then I have a 2 times negative radical 2. Gets me negative 2 radical 2. You want to make sure you bring the negative in front. Otherwise, it looks like you're subtracting it. And same thing for the y. On our y, it's going to be positive square root of 2 over 2, which is nice. It means the answer is going to be the same. It's just going to be the opposite sign. So I'm just going to shortcut a little and say, you know what? I think that's going to be a positive 2 radical 2. All right, and then we'll write it in the correct format. We have to put the x first plus the y and then the I. As you type this into Delta, make sure that this square root bar does not go all the way across like that to put the I underneath. Really important that the square root bar stops and you write the I afterwards. All right, going to get into a little bit more of a complex problem here with our multiplication. So again, our r and our thetas. X equals 2 radical 3, cosine of 7 pi over 6. And y, same thing except for a sine. I'll put this over 1. Put that over 1. And let's go find our answers for cosine and sine for 7 pi over 6. Let's see, 7 pi over 6 all the way down here this time. So that's going to be my x for cosine. And for sine, negative 1/2. So negative square root of 3 over 2. Negative square root 3 over 2. And for sine, negative 1/2. All right. I'll cross cancel the 2's. And then I'll multiply square root of 3 times square root of 3. That would give me the square root of 9, which would then square root down to 3. So x is going to equal negative 3. Don't forget about this negative right there. Again, this would have turned to negative square root 9, if that helps. And for the y's, the 2's cancel, and I just have a negative 1 times radical 3, which would just be negative radical 3, or square root 3. And then we'll write this together as one problem. So it's the x value. Normally I write a plus sign, but since this is a minus or a negative, I'll just go ahead and write it as a negative minus, and then put the I on at the end. Example 4, now would be a good time to pause the video. Try this problem on your own. Make sure you can get it. Fast forward a little bit, check your work. All right, so you should end up with 0 minus square root of 3i. All right, very nice job. Now we're going to go the opposite direction. So we're going to use those other two equations in that box, and we're going to try to write all of our answers in this format. So convert each rectangular complex number to a polar complex number. So this is the x, and that's the y. And we're going to use the other two equations, r squared equals and tangent theta equals. So r squared equals x squared plus y squared. So 1 squared plus radical 3 squared. We don't have to include the I, just like before, we'll add it on at the end. 1 squared is 1. Square root, square cancel to make 3. R squared is 4. Square root to make 2. Now for the tangent part. Tangent of theta, this equation right here, equals y over x. So make sure you use the y. Don't include the I with it. Over x. I'll simplify that down to just the square root of 3. The 1's not necessary. And then I have to go to my unit circle to figure out what my theta, what my angle is going to be. Remember, as you look at your unit circle, there should be 2 places where tangent is the square root of 3. I'll zoom out a little bit so we can see both of them at the same time. One of them happens right here at pi over 3. The other one happens down here at 4 pi over 3. In order to figure out which answer is correct, we have to look at our original problem and plot out where this would belong. So x is positive, I move forward. Y is positive, I move up. That would put my answer in quadrant 1. So as I look at my unit circle, I have to use this answer because it's the one in quadrant 1. So theta equals pi over 3. Now that we found r and theta, we're going to write our answer into this equation right there. So put the r in, 2, then a parenthesis, cosine of the theta, pi over 3, plus I sine pi over 3. It'll look just like that. Okay, example number 6. R squared equals negative 5 squared plus 5 squared. Negatives will always square off into positive numbers, so that'll be positive 25 plus positive 25. That's 50. Square root that, you do not get a whole number. You would get a decimal. We don't want decimals. We want simplified radicals. So we're going to take the 50 and break it down. Okay, I just checked delta math, and I believe that you can leave it as the square root of 50. I'll show you how to break it down just in case. You would have a 5 and a 10 and a 5 and a 2. Your pair of 5s would go on the outside to be 5 square root of 2. Again, I believe delta will accept the square root of 50. Then the tangent part. Y over x, and that just turns to negative 1. We'll go looking on our unit circle for where tangent is negative 1. Remember, there's going to be 2 answers. So in order to tell which answer, we're going to just do a short plot of this right here. Negative 5 means to the left 5, and then positive 5 means up. So we're going to make sure we grab our answer from quadrant 2. Quadrant 2. So in quadrant 2, we're looking for where tangent is negative 1 right here. And we'll write our answer as 3 pi over 4. All right. So as you write your final answer into delta, you could either write it as the square root of 50 or 5 square root of 2, whichever you prefer. Cosine of 3 pi over 4 plus I sine 3 pi over 4. And delta's nice. It's kind of got everything written for you, and it just leaves you a blank here and a blank here and a blank here. So it's pretty easy to fill out. All right, example number 7. R squared equals 3 squared plus 3 squared. And tangent theta equals 3 over 3. Yeah, now would be a good time to pause the video, see if you can do 7, maybe even example number 8 as far as you can, and see what happens. You can come back, unpause the video, and check your work. All right, so for example number 7, you have the 3 square root of 2 if you broke it down, or you could just leave it as the square root of 18. For a tangent, 3 divided by 3 is 1. This is happening in quadrant 1. And we get that at pi over 4. So we write our answer as 3 radical 2 cosine pi over 4 plus I sine pi over 4. There we are. Example 18. Sorry, example 8. Square that. Right here, I'm going to go ahead and throw a 1 in because I don't want to use I. So I'll use just a negative 1. All right. 4 is a perfect square, so I end up with 2. And then the tangent part. Y over x. Thing about that right there, it's not on the unit circle because it's not in the correct format. We're not allowed to have square root in the denominator, so what we need to do is rationalize the denominator, multiplying by the square root of 3 over the square root of 3. You don't want to do any cross-canceling. That'll lead you back to where you were originally. Instead, you just want to multiply across the top and bottom. Multiplying across the top gets you negative square root of 3. And multiplying across the bottom, radical 3 times radical 3, radical 9. Radical 9, square root of 9, regular 3. Find the quadrant that you're looking for your answer in. It'd be positive forward and negative down. So you're looking in quadrant 4 for negative square root of 3 over 3. Right here, which means we're going to be using 11 pi over 6. Bring down the r. Cosine 11 pi over 6 plus I sine 11 pi over 6. And there we are.